Here is an example of the nomographs that I created to estimate the asphalt cooling times. As you know, the cooling time is based on a number of factors, including the temperatures of the ground and air, the height of the lift to be laid, and the amount of sunlight, just to name a few. I think your idea of simplifying all these into rule of thumb guidelines was excellent, and your suggestion of a nomograph turned out to be a perfect way to do this. That's because there are two dominant factors that affect cooling time: the ground temperature and the wind speed. As I'll show you, we can get a rough estimate of the cooling time using just these two parameters, and then tweak this estimate if we want to, if any of the other parameters are way different from the baseline conditions we used to generate the nomograph. Okay, this nomograph is for a 1.5 inch lift. This nomograph here is for a 2-inch lift. As you can see, there are 3 vertical number lines that correspond to 3 different things. The one in the middle is what we're trying to find out, the cooling temperature. On the left and right are the ground temperature and wind speed, respectively. For these nomograms, I'm using a temperature of 220 degrees. As you know, the magic in the nomograph is the irregular spacing on each of these number lines, as well as this horizontal spacing between these 3 number lines. There's a good bit of math behind this, but the result is very elegant. Now, for both of these nomograms, I've assumed everything but the lift height, the ground temperature, and the wind speed to be the same all the time. As you can see here, I made a lot of assumptions in making the nomographs, but these parameters have a less significant effect on the cooling time. However, I've included rules on how to modify the nomograph times if the actual paving conditions are very different than those I assumed. I'll show you 2 examples. The first is a pretty common example with only a few optional modifications to make to the nomograph prediction. The second example is one that requires more extensive modification, but becomes more accurate with each correction. In the first example, we are laying down a 2-inch lift at 10 a.m. on a cloudless August morning here in Louisiana. The ground temperature is 90 degrees and the air temperature is only a little warmer, let's say 95 degrees. That'll give us a air temperature of, I'll put G plus 5, meaning ground temperature is 5 degrees hotter than that. There is a light wind of 6 miles per hour. When the asphalt truck arrives at the site, the mixed temperature is measured to be 300 degrees. So we'll start the prediction with the nomograph for the 2-inch lift. We find the ground temperature on the left, 90 degrees, and the wind speed on the right. Drawing a line straight between them gives an estimate for the cooling time of about 14.5 minutes. Let's look at the effect of the air-ground temperature difference. The air is 5 degrees warmer than the ground. Since we see that it takes 10 degrees of difference to affect the cooling time by even 30 seconds, we can ignore this 5 degrees, this plus 5 degrees. Being August, the deep ground temperature gradients are different than in December, and this increases the cooling time. In July, we would add a half minute. August, yeah, that's close enough, so let's add a half minute to our prediction. At 10 a.m., the asphalt is going to experience more solar heating than at sunrise. At noon, we would add a full minute. We're predicting this at 10 a.m., so we'll add another 0.5 minutes here. Therefore, our final prediction, 14.5 plus 0.5 plus 0.5, 15.5 minutes to put down and roll the hot mix. In the second example, let's imagine we are putting down a 1.5 inch lift on a January, say about 2 p.m., a day or two before a cold front passes through. That means it's warmer than usual, so the air temperature of 70 degrees is a good bit more than the ground temperature of 56 degrees. I'll give you plus 14 degrees here, or G plus 14. It is overcast and breezy. The nearby airport is measuring winds of around 15 miles per hour. However, the paving site is on our side of town, so the trucks are arriving with the hot mix at a nice 320 degrees. Going to the nomograph for the 1.5-inch lift, we will mark the ground temperature, 56 degrees. We will mark the wind, 15 miles per hour. We'll draw a line here to connect these two. This gives us then a cooling time of 6.25. The air is nearly 15 degrees warmer than the ground. So let's add 0.75 minutes to the cooling time. Looking at the month, we can see that January is close enough to not require modification here. We're in the early afternoon, so maybe let's add a minute. The day is overcast. So let's take a look at this. This graph here shows how we will correct for this. We will use the blue line since that is the one for the 1.5-inch lift. What is interesting about the sky cover is that if the cooling time predicted by the nomograph is large, then the cloudiness has a large effect. If the nomograph time is short, then cloudiness has a small effect. That's what these lines give us. Okay, for this example, the nomogram predicted a cooling time slightly more than 6 minutes. Therefore, because the sky is overcast, we'll need to subtract about a half a minute, minus 0.5. The final modification we'll look at is the delivery temperature. In this example, the hot mix is 320 degrees. Since the nomogram estimate was just over 6 minutes, then we will add a minute, just about, for every 10 degrees away from 300. It's hotter than 300, so we're going to be adding. If it were less than 300 degrees, then we would need to subtract that time from our cooling temperature. A little bit over 6 minutes, about add a minute to our cooling time. Now this is 20 degrees over, so we're actually going to add 2. Adding together all of these modifications, we'll see that we will have about 9.5 minutes then before this asphalt mix gets too cool for us to work. Now, I have not included modifications for other parameters. For example, the mix type and binder grade don't really affect the cooling time. However, they may justify a higher or lower temperature limit instead of the 220 degrees. In addition, the paving surface can alter the cooling time, and the latitude can also, but these alterations are relatively minor. So that's a summary, David, of how to use these nomograms. Thanks again for your guidance on this project. I'd be glad to incorporate any further suggestions for improvement that you may have. Thank you.